Hey everyone, and thank you for joining me. Today, we're going to be discussing how to factor a quadratic equation. So, a little bit of background. These usually follow the form ax squared plus bx plus c is equal to 0. Now, you may have seen this before, and we're not too worried about what a quadratic does. We just want to factor it for today's purposes. So, first off, we're going to factor out a from all terms. So this is going to leave us with 0 is equal to a. And then remember, when we factor something out, we divide everything inside of the brackets by it, like we discussed last time. So a x squared plus b over ax plus c over a. We're going to follow that up by finding the factor pairs of c over a. So that's going to be two numbers that multiply to c over a. This is pretty much the factors that we discussed last time. And then we're going to find which of these pairs adds to equal to b over a. And when all is said and done, we're going to get something in the form a x minus r x minus s that we can plug right into this equation. Okay, so starting with this first example right here, we have 2x squared plus 6x plus 4. And if you remember from last time, this is actually the example that we left off on. So we're going to start by writing what a, b, and c are equal to here. A is equal to 2, b is equal to 6, and c is equal to 4. So the first step is going to be to factor out a from all terms. And I'll just write that that's equal to 0. So I get 0 is equal to 2, x squared plus, and then off to the side, I'm going to solve for b over a, which is 6 divided by 2, or 3, and c over a, which is 4 divided by 2, which is 2. So I'm going to get, in the inside, x squared plus 3x plus 2. Okay, so that was step 1. Now for step 2, I want to find the factor pairs of c over a, which is going to be 2. So the question then becomes, what are the numbers that multiply to equal to 2? Well, we have 1 and 2. And a little bit different from some of the examples last time, we're going to consider negative numbers as well here. So remember that two negative numbers are going to multiply to equal a positive number, right? So we'll have -1 and -2 there. So then question 3 becomes, which pair adds to equal b over a or 3? Now, -1 plus -2 is -3, so that's not the pair that we want to discuss. Instead, we're going to want 1 plus 2, which is 3. So what we're going to get as our answer here is 0 is equal to 2, x plus 1, x plus 2. Okay, so I have the following example here, which is x squared plus 7x plus 6. Now, if you look on the left side, you can see the rules that we've discussed so far, just as a quick refresher of what to do. So, we're going to start by setting a equal to 1, b is equal to 7, and c is equal to 6, just because we're following the form ax squared plus bx plus c is equal to 0. So, the first step is going to be to factor out a. Because a is 1 here, we actually don't have anything to factor out, right? So at the end of step 1, we're just going to be left with 0 is equal to x squared plus 7x plus 6. Okay, so to continue with this example, we now need to find the factor pairs of c over a. Well, c over a is going to be 6. So all the factor pairs of 6 are going to be 1 and 6, 2 and 3. And remember that we have to consider their negatives as well. So -1 and -6, and -2 and -3. So these are the four factor pairs that are going to multiply to equal 6. Now for the final step, we just want to find which pair is going to add to equal to b over a. Now b over a is going to be 7. So we see that one and 6 are the two numbers that we want, right? 1 plus 6 is equal to 7, and 1 times 6 is equal to 6. So as our final answer, we're going to get 0 is equal to x plus 1, x plus 6. The following two examples. So if you don't have the rules I mentioned before written out, or if you don't have them memorized, I'd recommend just going back to the clip before and writing them down. It will be very helpful for you learning how to master them. So we're going to start with the example on the left. So first thing we're going to do is write a is equal to, here we have 1, b is equal to 7, and c is equal to 12. So the first step, we have 0 is equal to, well, factoring out 1 doesn't change anything about the formula, right? So we get x squared plus 7x plus 12. So 2, we want to find the factor pairs of c over a. Well, here c over a is going to be 12 over 1, or just 12. So factor pairs of 12 are as follows. We have 1 and 12 multiplied to equal 12. We also have 2 and 6. And we also have 3 and 4. We also have their negative counterparts. So negative 1 and negative 12, negative 2 and negative 6, and negative 3 and negative 4. So now the question becomes, which of these 6 pairs here is going to sum to equal b over a? Well, b over a is equal to 7, right? So if we look into each of these different pairs, you can see that 3 and 4 is the winner. So as our final solution, we have 0 is equal to x plus 3, x plus 4. And now continuing with part B, which is on the right here. So we're going to start by writing out a is equal to 3, b is equal to negative 24, and c is equal to 36. So factoring out 3 is going to have an impact here, right? So we're going to get b over a, which is negative 24 divided by 3, or negative 8, and c over a, which is 36 divided by 3, or 12. So for step 1, this is going to leave me with 0 is equal to 3, x squared minus 8x plus 12. Okay, so from here, we want to find the factor pairs of 12, which you can see it's convenient that we have them written on the left side here. So I'm not going to go ahead and rewrite those because we can just look to the side and see them. So then the question becomes, what are the factor pairs of 12 that are going to add to equal negative 8? And you can see that negative 2 and negative 6 are going to be those, right? So we're left with 0 is equal to 3, x minus 2, x minus 6. And remember that this is just following the form 0 is equal to a, x minus r, x minus s that I showed earlier in this video. Okay, so I wanted to pick up with this example right here. And really the point of this one is that to show if a is negative, we always factor out that negative, but if b or c is a negative number, we just leave it and roll with it. So here a is going to equal to negative 2, b is negative 4, and c is equal to 30. So factoring out a, because it's not equal to 1, is going to change this equation. So we're going to take b over a, which is negative 4 divided by negative 2, right? So those negatives are going to cancel out, and we're just going to be left with 2. And then we have c over a, which is 30 divided by negative 2, or negative 15. Okay, so to start us off, we write 0 is equal to negative 2, x squared plus 2x minus 15. Okay, so now for step 2, we're looking for numbers that are going to multiply to equal negative 15, or their factor pairs. So because negative 15 is obviously going to be a negative number, that means that its factor pairs are always going to be one positive and one negative number. So, for example, 1 and negative 15 is how we can write that. We can also write negative 1 and 15. We can also write 3 and negative 5. And we can also write negative 3 and 5. Okay, so finally, the question becomes, which pair adds to equal to b over a, or 2? And you can see that the answer here is going to be negative 3 and 5. So, as a final answer, I get 0 is equal to negative 2, x plus 5, x minus 3. Okay, so the following example has 2x squared plus 28x plus 48. And I've left the instructions on screen for how to factor this. So I'll get you to pause the video, try this problem, and come back when you're ready. Okay, so the first thing that I would have started with here is writing out what a, b, and c are. So we have a is equal to 2, b is equal to 28, and c is equal to 48. While I'm at it, I'm going to compute b over a, which is 28 divided by 2, or 14, and c over a, which is 48 over 2, or 24. Okay, so for step 1, this is going to leave me with 0 is equal to 2, x squared plus 14x plus 24. Alright, so for step 2, we want to find all the factor pairs of the number 24. Well, this is going to leave me with 1, 24, 2 and 12, 3 and 8, and 4 and 6. Now, it's a positive number, which means I have to consider positive times positive and negative times negative, right? So I'm going to also have negative 1 and negative 24, negative 2 and negative 12, that should be a negative 3 and a negative 8, and a negative 4 and negative 6. Okay, so for part 3, I want to find which pair is going to add to equal b over a, or 14, and that's going to be 2 and 12 right here. So that leaves me with an answer of 0 is equal to 2, x plus 2, x plus 14 as my final answer there. Okay, so same thing for this example. I'll get you to go ahead and try it on your own and come back here when you're ready. Right, so we're going to start by defining each of our terms. A is equal to negative 3, b is equal to 18, and c is equal to negative 24. Well, this is going to leave me with b over a is equal to 18 over negative 3, which is negative 6, and c over a is equal to negative 24 over negative 3, which is going to be 8. So, as of step 1, that leaves me at 0 is equal to negative 3 x squared minus 6x plus 8. So, for step 2, I want to find the factor pairs of 8. So, that leaves me with 1, 8, 2, 4, and the negative versions. So, negative 1 and negative 8, and negative 2, negative 4. Okay, so now that I have these established, I want to go ahead and find which pair is going to add to negative 6, right, or b over a. And that leads to negative 2 and negative 4 being the numbers that I want. So I get 0 is equal to negative 3, x minus 2, x minus 4. Okay, so for the last part of the video, I just wanted to expand a little bit on our concept of how we can use this and how it relates to some of the other stuff that we've learned. So, from the expression 0 is equal to 5x squared plus 25x minus 30, it wants us to start by factoring the expression. So, we'll start with a. For a is equal to 5, b is equal to 25, c is equal to negative 30. This is going to give us b over a is equal to 25 divided by 5, which is 5. And c over a equals negative 30 divided by 5, which is negative 6. So I get that for step 1, 0 is equal to 5, x squared plus 5x minus 6. And so for step number 2, we are going to ask ourselves, what are the factor pairs of negative 6? So what are two numbers that multiplied equal negative 6? Well, there's 4 combinations, right? We have 1 and negative 6, 2 and negative 3, negative 1 and 6, and negative 2 and 3. So question 3 becomes, what numbers are going to add to equal 5 of these ones here? Well, negative 1 and 6 is the best option, right? Negative 1 plus 6 is equal to 5. So that's going to give me an answer of 0 is equal to 5, x minus 1, x plus 6 in factored form, which is 5 x minus r, x minus s in this case. So for part B, what are r and s? Well, in this case, you can see that negative 1 is equal to negative r in the equation, right? Just because that's where they happen to line up. So I just get that 1 is equal to r. And then we also see that 6 is equal to negative s. Now that means that negative 6 is equal to s. So what do r and s actually mean? Well, in terms of quadratics, 1 and negative 6 are going to be the zeros of the function, or where the function intercepts the x-axis. This is an important concept that we're going to come back to time and time again. Okay, so now that leaves us with example C. So we're going to start from 0 is equal to 5, x minus 1, x plus 6, and we want to expand the expression to see what happens to it. So how do we expand this expression? Well, you might remember it's a combination of foiling and the distributive property. So we're going to start by foiling these here. So remember, foiling goes firsts, outsides, insides, and lasts. If you need a quick refresher on foiling, by all means, go ahead and check out that video. So that's going to be 0 is equal to 5, x times x, plus 6 times x, plus x times negative 1, plus 6 times negative 1. Or 0 is equal to 5, x squared, plus 6x, minus x, minus 6. Okay, so collecting the like terms on the inside, I'm going to get that 0 is equal to 5, x squared plus 5x minus 6. And at this point, we use the distributive property here, which is going to get us 0 is equal to 5x squared plus 25x minus 30. Now, if this looks familiar, that's because it was written right up here, right? It's the expression that we started with. So basically, the factored form is another way of writing the standard form. Okay, so that's everything for today. Thank you very much for your time, and I hope to see you again soon.